Alrighty, so I'm gonna do another session, taking another break from my actual responsibilities. So I'm just gonna do some more programming on chess. I was thinking about how I can test my alpha beta pruning procedure that I started yesterday. Yesterday I programmed alpha beta pruning, and I wasn't sure if it was working. I still don't know if this is the best way to test it, but I'm gonna give it a particular position that has some properties that should be what's the word, conducive to good pruning. So this is a situation where an algorithm, well, right now I have Stockfish running, so Stockfish right away sees that this is a mate in two for black, and that it's a ladder mate, and there's a couple of properties. I generated this position. It's weird if there's three rooks. This is probably not going to happen in a real game, but I generated it to have this idea that the only captures available to black, so it's black to move. So there's two captures available, and our current algorithm will look at captures first. So it'll consider one of these two captures. I'm not sure which order it'll choose. I'm not sure which one it'll pick. It turns out that if we did make this move, well, actually, so white can take back, but that's not the best move because white has enough material that it can win. So if we were to make a bad move like this, then here Stockfish is suggesting the queen goes here, and then we get a ladder mate the other way, going in favor of white, right? But even more greedily, like if the algorithm's playing greedy and is not considering checkmates, it might even just do something like this and take the free rook with the skewer. But that would be a bad move because then black can, well, white's still winning, right? It's still mate in 7, it says right there. So anyway, so one of the things that's nice about this position, or actually interesting about this position, so starting from here, is that there's only one move. There's only one move for black, but there's a bunch of moves that you can't tell. You can't tell that there's only one move because unless you look ahead, a lot. And so probably what I would guess alpha beta pruning would do is it would explore this combination. It would consider all the possible legal moves for the king, which there's 3 legal moves. It would try all of them, and all of them end in mate, right? So you can do that, and it ends in mate. Can I go back? Yeah, no matter what you do, you end in what? Why? Okay, the arrow keys are not working. Oh, it's the arrow. My cursor was inside the fen field. Okay, so yeah, so no matter what you do. Not there. So no matter what you do after this move, it's mate. So it'll quickly discover that move is mate. It will also consider this move, so I don't know what will happen when it does that. That might take a while to calculate. So the reason that I set this position up in this way is that white has a lot of moves available, right? So if we make some random move, white has, the queen can go here, 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 here. The rook has all these squares available. The king can move, sort of. I mean, there's a few spots for the king to move. And then these pawns can advance. This board is weird. This is from black's perspective, so the pawns advance downward, even though this looks like a pawn chain. Just don't worry, it's a made-up position. So that will mean that calculating what to do next, if you have a lot of options available, will be really expensive. But what you should... what we should find is that, if you think about what my algorithm is going to do, the way I currently implemented it, it'll sort of, take this, it'll consider taking that piece, which is a decent move. But it'll explore this, and ideally it quickly finds that this is better for white than the other option, which was a mate in 2 for black. So I'm not completely sure, but my guess is that this should be pretty fast to calculate, even though there's a lot of moves available for white on the next turn. So let's try it. So I can plug it into my custom engine testing setup. So I'll just do this. All right, so we will do this with. So this is currently the current setup right now is it's going to go to depth 4. I think goes to depth 4, and this configuration I have it set to. Whoops. Right now I have it set to. I don't like this dark mode. I don't know why I went to dark mode. Let me change it. I know some people like dark mode. I have some glare on my screen, so white background is a little better for me right now. Let me change that. Let's do Mac OS Light, so it matches my operating system. Okay. So, yeah, I don't know. Sorry if that's blinding, too bright for you, but I don't know. I want it light mode when in the daytime, and it's daytime here. So okay. So let's do this. So this would be without any pruning, but I don't even care about that. I want to see the pruning work. So let's do prune. Well, let's do the comparison. So we'll do both. This might take a really long time. No, let's just do pruning. All right. So we'll just turn on everything. We'll do the pruning with all the tricks on, and what we should see is some. I'm hoping this won't take long. I'm hoping it'll calculate it pretty fast, but I might be wrong. Let's see. Yeah, that's slower than I want. So I wonder why. Let's see. If we think about what the computer's doing, it's probably still exploring a lot of different options for black. And there are quite a lot of moves available for black, right? Alternative moves. Let's see. Let's look at the board. Well, okay, it finished. Let's look at the stats and then we'll go back to the board. So it said it took 26 seconds to calculate to depth 4. It considered 33,000 positions. That's a lot. I was hoping it would do fewer than that, but I guess so. If we look at the board, let's think about, so from black's perspective, it has it has all these options, right? This rook can move everywhere basically. This rook has a lot of options. This rook has a lot of options. So it has to consider all those for sure. The question is, how quickly can it identify that those were bad moves? So for example, if it moves here, I mean, exploring to depth 4, I guess there's still a lot of things to consider. I mean, again, this is Stockfish. It's super optimized. It knows that this is a mate in 3. But if you turn off Stockfish and you pretend we don't know the rules of, if we don't know the rules of chess and we're just sort of a computer just sort of watching things move as we make decisions, it's a little bit hard to imagine what the right move is here. So you have to consider this capture, in any other game position, that's a material gain, right? You win the exchange. Seems pretty good. Similarly, you can consider this, or which is a skewer, which you can then win a free rook. Seems like a pretty good move. It turns out it's not a good move. Well, it is, but it's not the best move in this situation. So there's a lot of things to consider. So I guess it's still understandable. It's a little tricky. I've been trying to design a position where we can really see alpha beta pruning work, but we can just move on. I think what I really want to do today is improve the sorting heuristic. So looking at this position, one of the things that alpha beta pruning does is that it has a strategy for deciding which move to look at first. And the right now right now the strategy I have is that it's choosing the move that has the best material advantage for the current player. So in this case, it would be any that would basically mean any capture, right? Any capture, and the best capture is the one that it looks at first. So what that doesn't realize is that a capture might not be good, right? In fact, let's see if we just move a couple positions around. Let me see if I can show you an example of this. I mean, a simple example is this, right? So if I, let's say I threaten the queen. This is not a real threat, right? If you know chess, right away you can know the queen can take back. But this capture looks just as good as the queen taking back, and in fact, neither of them is the correct move, because you can get a checkmate by going like this without even capturing back, right? You can force checkmate this way. So so the idea that a capture might be the first thing to explore is just wrong, right? Here in this position for white, considering the captures first is not a good idea, right? So that goes, one of the things you learn in chess is oftentimes it's a good strategy to check to consider your checks, then your captures, then your attacking moves, and in this case the check is better than the capture, which is already a rule a lot of human chess players know, but this computer doesn't know that. So one strategy I could do is I could consider like hard coding that we put a check as one of the things to consider first. But I'd rather do something else. So first, my plan is to change the code so that I can swap in that the sorting function, and try different ones and see how it performs. So to do that, I'm going to add a configuration, a term into the configuration object. So I have this thing. This is the name tuple. It contains all the configuration parameters for the search algorithm, and I'm just going to add another parameter, and we're going to call it sort heuristic. So it's going to be, and by default I'll do material count. So I've set up the configuration so that it's now going to choose a sort heuristic function, or you can choose a sort heuristic function in the configuration, and it'll use that. So now where that fits is down here. So the way I had set up the search algorithm is that it would generate all the possible next positions you can get to with all from any legal move from the current position, and that would append to a list of children, game states, a sort score and the board and the move that came from the move that leads to that new board position. And this sort score was the material count. So instead, I'm going to change this to config.sort heuristic. Heuristic. I want to put this feels nicer if it's on a new line, but I don't know if that. Oh, that's okay. I'll just do So Python lets you break lines with a backslash, and this that seems okay. All right, so now this is going to use the sort heuristic, so we can change that on the fly. And then what happens is the search algorithm will consider the moves in order according to that sort heuristic. So let's change these configurations. So I want to keep the pruning on, and I'm just going to change the sort heuristic. Let's keep it material count. In fact, I'm going to leave these as the defaults. So these are all by default, these are all on. So we're going to try that, and we're going to try. Excuse this. I don't know if you can hear it on the microphone, but there's construction going on next door, so you might hear some sawing, or power tools going on back there. Okay, so let's try a different sort. So I'm going to use a sort heuristic. This time, what I want to do is sort by the current best estimate of the score for the position. So let's call it cache score, and I have to make this cache score function. So I'm passing in a function. So material count is the original thing I had, which was just counting up how many pieces you have versus how many pieces the opponent has. Sorry, not how many, but the value of the pieces you have and the value of the pieces the opponent has. So I want to do a cache. I'm going to define a new function that's going to be the cache score. Cached score. Oh shoot! I have to. Somehow it has to have access to the cache, right? So going back. Well, first I'm going to give it a new board and turn, and I'm going to there's a couple refactorings I can do here. I think one thing is that I've never calculated the score. I've always anytime I calculate a score, I've been passing in turn as a flag to see who's which player has the move in the current position, but that's actually stored in board. So if we look at the Python chess documentation, I think that's stored in the board object. Let me send that over here. Okay, so and so I don't actually need that. I think I can just I can drop it from every single time I call those functions. Let's see. I want to look at dot turn maybe. Not found. Turn. It's not all caps. Okay. I think maybe in board. Turn chess color. Yeah. So it shows whose turn it is. So I should just be pulling that out of the board instead of. I don't think there's any time I call it where I need to flip this. So I'm going to remove that, and this is just going to be new board dot turn. I think the one tricky part is, well, let's see. So okay, so I'm going to remove that. Anytime I do this, I'm not going to require the turn to be passed in anymore, and this will just be new board dot turn. So I'm just refactoring a bit. So here's where things get a little tricky, right? So I'm when you have to consider the other player, I've been using not, and I've said this multiple times. I don't love this because I know that Python chess implements the turn as a Boolean function, or not a function, a Boolean variable. So it's just a true or false. I think it's probably whether it's the white player's turn, but not sure. And so I can flip it, right? I can say the other player by saying not, but that's not great. It's not a good strategy because at some point Python chess might change how they implement that. Suppose they, I don't know, suppose they improve their code so that they can handle 4-player chess, right? If they did that, then my code would break if I do this. So it's probably better for me to find a way to figure out like what actually, can I see opponent maybe? Opponent, let's search for opponent. Yeah, it doesn't show. It'll work for now, but I should just be aware of this, right? Every time we do not, it's not really, or not turn, it's not correct, or it's not the proper coding way to do this. Okay, so turn. I have this minimax score for the turn. I think I don't actually care. I mean, I don't want someone to pass in the turn because I'm always going to be working with the turn of the current board. So I'm actually going to pull that out here automatically. So turn equals board dot turn. And the important thing is that there's some funny stuff that will happen here because now we're applying the sort heuristic with not turn. I don't need that. Where else does turn appear? Let's see. So in this loop, we're considering we have not turn. I don't think we need that because we always just care about the other player's turn. Every single time we sort of just flip whose turn it is. So it's just whatever turn is represented in the new board object. So we don't have to change it, or we don't have to explicitly change it because it automatically changes itself. Okay, best score. Everything looks okay. I think I'd probably call it here somewhere. Board.turn, so I don't need that. So that's a little bit nicer. All right, so it might work. So let's see, cache. Let's just check if all the code works. So as I implement this cache score, so right now this is not going to run because there's a syntax error because I had to finish this function. One thing I can just do just to check material difference. I'm going to return the material difference. So cache score does nothing different than material difference. Why is it complaining about this though? Unresolved reference. Material count is what I called it. Okay. Count. Okay. So let me just add the correct number of spaces to fit Python style. And then that should work. So this should run. It won't do anything, right? So rather, these two calls will be identical. They shouldn't be any different. And let's just run it. Just to speed things up, I'm gonna run to max depth 3, just so we don't have to wait as long. But eventually we'll test it with larger depth. Okay, so there's a bug. So yeah, I didn't catch one of these times where I used turn. So let's find where that is. It's up here. Oops. Okay, that is here. Okay. All right, it's running with the old material count. That took 4 seconds, 4.7 seconds. This took 5.0 seconds. It's probably not. That's probably just randomness. But we should see the same numbers. The number of cache hits is 1024. That's a weird coincidence. That's a very round number in computer science. But there's no reason for it to be a round number right now. Prunes, 1018, 1018. Okay, yeah, same behavior. That's what we wanted, and same move. Wait, just out of curiosity, F3 G3, is that what we wanted to get? I don't. There's a way for me to have it output more standard algebraic notation for chess moves, but right now it's so F3 G3. Yeah, so it found the correct move. And is this consistent with what we think? So this is with I have it set to look ahead 3 moves. So it consider this move 1, and then consider another move, and then 3 is a checkmate. So yeah, this is the limit of its ability to look ahead. If this position were different, where you needed more steps to ladder mate, then, like for example, if the king was on the F file, I don't think my bot would be able to find that, right? Because it can't look ahead that far. And one of the things about checking a king is that it doesn't change the material advantage. It might lead to checkmate, but you have to look further down in the game tree to really know for sure that it's a checkmate. So anyway, this is shallow enough that my bot's able to find it. All right, so let's try changing the sort score. So just for a comparison, I'm going to, as a control, let's try returning something stupid. So we're going to return 0. And we don't want to do this for sure, but what this is like not going to sort. We will no longer be sorting the moves in any reasonable order. And when we run it, we should see different numbers here, and we can talk about what those numbers mean. Okay, so this is the first version using the material count as the sorting function, and then now this is the second version using random sort, and it actually does better. Does it do better? Let's see. It was faster, right? 3.79. This was 4.5. So the sorting by material count actually slows things down compared to like random sort. It's not random. It's probably sorted by the order that Python chess returns the moves. I don't know what that order is. I don't know. Maybe it starts with. Yeah, actually, we don't really know. Yeah, I mean, I think what this means is that my material sort. I think we can see some of these things happening in the next move. So sure, the best move is this one, but if we choose a different move, well, that's a terrible move. But let's choose this one. Like, it's an innocuous move. Again, Stockfish right away sees that there's a mate in 2, but our algorithm is going to consider things like captures. Like, it'll consider this capture, and then the game gets more complicated, right? We suddenly went from mate in 2 to mate in 7. So now it's it would consider maybe this capture, which is not a good move. Then white would consider this capture. I mean, it would go down this path looking at captures until it realizes all these captures lead nowhere, and then eventually it'll find there's these other paths that are not captures that lead to checkmates in either direction. And yeah, those checkmating moves are not sorted in any special order. They appear They appear later in the sort order if we sort by material count. So the fact that I didn't sort in the second run, right, in this run here, this the bottom one highlighted here, the fact that I didn't sort actually made it faster than when we did sort by by material count. So what's the strategy here? So I'm thinking that I want to do two things. So the first thing I want to do is I want to sort by whatever's in the cache. Now the question is, how do I get the cache? So the cache right now is only being accessed by, so Minimax score has access to the cache. It's passed in by, this is Minimax score. So if I go to score engine, I have my score engine object. I have a known positions data, dictionary. This is a dictionary. It contains a cache. It stores all the positions that we've seen so far and what score we evaluated it to be. And it remembers how deep we looked to evaluate that. And we're not going to use how deep it was at this time. I don't want to recompute things. I just want to look it up. So I want access to this. So how do I get access to this? I think what I'll do, I have an idea. I will put this inside that function. So this is going to be, this is tricky. Okay, one idea I had, where is it? So this is, I'm going to move this. I'm going to move it into the class. So score engine will now have a special function called cache score, which will have, oops, that's not what I meant to do. It will then have access to the cache score. So it will return it will return self.known positions. Oh shoot, I have to do, let's do it this way. Score equals, I think I store the depth. Yeah, it's score then depth. Okay. So I'm just going to ignore this. I'm going to ignore the second quantity in the dictionary, and we're going to say equals self.known positions new board. Oh shoot! You know what? This is a little ugly. So the way that I access the cache is with this special manipulated fen code. So the fen string representation of a position, it contains the move counts, and we drop the move counts here. So I'm just going to, for now, I'm just going to copy this. At some point we need to refactor and combine this so that I don't have to change it in two places. So I'll just put it to do here. Refactor to create standard modified fen. Is fen, I guess fen is an abbreviation, or it's initials for something. What does fen stand for? Well, it's they write capital FEN. It stands for, okay, let's just Google this. Chess fen. Forsyth Edwards notation. Okay, so it's named after people, so yeah, so it should be all caps. This is not important, but I like to be somewhat consistent with style. Okay, okay, so now I have the fen, and I'm just gonna use that to look it up. And so here's the tricky part. So I guess I'm going to say if fen in self.known positions, then we return that, return score, and otherwise we will return material count new board. All right, so here's the logic here. If we have seen this position before and we've thought, enough about it to look ahead, then we're going to use that as the score, and it's going to be it's going to come out of the cache, and that's great. On the other hand, if we haven't seen it before, then we're just going to return the material count, and we'll be back to where we were, which is again not ideal, but in many situations it's better than not sorting. In the situation that I set up, it's like a trick situation. It's where a move that is not improving your material advantage is actually better for you because it leads to checkmate. So that should work, sort of. Now the problem is, how do I now pass in? Sorry, I'm trying to jump to this error. So there's going to be an error here because I pass in. I want to pass in cache score for the configuration, but I can't do that because I have to, because the score engine doesn't yet exist, right? So what I want to do is something like engine dot, what do I call it, cache score. I want to do that, but engine doesn't exist, and we create engine down here. So I have to do some redesign or reorganization here. So let's think about this. What is the best way to do this? I could I want to make this super modular, right? So what I'm trying to do here is I'm allowing any function to be passed in as the sort heuristic. But another way I could do this is I could just say it's a flag, right? It's true or false. And I could just make it true. If it's true, it could like turn on this cache score. I could do it. I don't know. It's a little hacky. There's always a trade-off when you develop these things between doing it fast and testing it out, and doing it right, so that you can make more elegant changes later. I wonder if there's another strategy here that I'm missing. I guess. Okay, I'll just do it that way. So I'm going to say this is false, and I'm going to say this is true, and I'm going to change the name of this. Let's go, can I change it like this? I'm going to call this cache sort. Sure. Okay, oh, it didn't work. Okay. Yeah, I was hoping the IDE would discover what this is and be able to change it everywhere. I hope it didn't mess anything else up. So okay, where do I want to fix that? So I have that at here, cache score. That's fine. Search seems fine. Cache self config. Okay, so I think it will be in here. I don't love it. I really wish there was a cleaner way to do this. So right, this seems so elegant, right? But the problem is I need to pass in. I have to pass it in from the class, the score engine class. So the score engine class gets. Score, it's fine. So the functions inside the config object. So if I put it, I can modify the config object, but that feels a little bit bad because it's modifying something outside the scope of the function. which could lead to some side effects, and unexpected behavior. So I don't really want to do. Oh, you know what? I can't even modify it because something. This is like a little, way under the hood Python stuff. But like this thing, which is a named tuple, is something that's not mutable, right? So you can't change it. It's that's I'd have to create a new one. So that's annoying. Another thing I could do is I could change the minimax score to take in an actual function. I don't like that idea. I prefer. All right, so I prefer the way it was. So now the question is, how do I get this to be? So let's change this back to what it was, which was sort heuristic. And this was material count. And this, I wanted to set it to something. So what do we set it to connect it to? I guess we can't. So I guess I will hack this in. No, I can't hack it in. I can do this with I could create the engine before. The problem with that is I don't want to reuse the cache. But I can clear the cache. Let me do that. So I'll do that. I'll create the engine. Yeah, here's what I'll do. Okay, so I'm going to create the engine before. All right, so now we can, oh shoot, but it gets the config. This is all so circular. All right, undo. Okay, let's think. What's the cleanest way to do this so that I don't create bugs that I have to fix later? What if I oh man, this is quite annoying. All right, I will just, especially because, okay, here's the other thing I haven't said yet is that this isn't going to do anything. It won't really work until I actually start filling that cache with something. And I'm going to fill that cache with stuff. Well, it'll work if you, like, as you play a game, you'll see different positions being evaluated more than once. And then the cache will actually help. So we might actually see like the, we won't see it with the test that we're doing where we're only looking at one position at a time. But actually, yeah, okay. So I'm totally stumped. What's really the clean way to do this? I think I just need to reorganize how I do the configuration. I'm sure this is not the most exciting viewing. I wanted this video and the stream to show you some cool chess, but here I am trying to figure out how to organize some configuration objects for my classes. So let's go back to what I had. So I had done cached score, and now maybe I need to pass in cache score. Config cache score. What if I just, all right, I'm gonna do a hack. Here's the hack. I'm going to put it inside the engine, but I could put it outside the engine. I just need to give it a cache. But it doesn't, there isn't, All right, let's just do this. We will say All right, this is a complete hack. So I'm gonna say false, which is just like a placeholder. And what I will do is here I will say if, this is so ugly, very ugly hack to try to get some quick experiments. Okay, so if config dot sort heuristic, let's say not config equals, now we can set it engine dot cache score, and now it'll work. This should run. It won't be very different because I don't think there's not much in the cache right now, but it might be slightly different because sometimes you do revisit a position. Okay, and it did not like that because what? So it says bool object is not callable. So somehow my change did not work. So where are we? So if not config sort heuristic, let's do some debugging. So I'm looking at the code as it runs. The first time it goes through, it should be using the material count function. So here it's using material count, which is good. And then the second time it gets here, it'll take a few seconds. It's slower now because I'm using the debugger mode. Okay, so it made it through the first round, and now the second round, what do we see? So sort heuristic is false, which is what I wanted, but then why is this not happening, right? So if not config sort heuristic, let's try this. So I'll copy that. There's a tool here. I can tools. I forgot where to do this. Oh, here, this little button here. So I can calculate this. What does this tell me? It says true. So it should evaluate. So it should go in here. So let's step forward. Yeah, it went forward. And then I guess let's go one more. Config now says sort heuristic is score engine cache score. So why did it not work? Oh, I know, because yeah, because I've already initialized the engine to have the wrong config. So actually I need this to happen before this line. That's what happened. Okay. So yeah. So I want to go up here like that. All right, so now I'm changing the config before I activate the engine using that config. Okay, here we go. This should work now. Okay, round one using the material count sorting, same numbers we saw before. Round two, cache hits, a lot fewer cache hits, more prunes, and fewer positions. It actually, looked at fewer positions, even though it took longer. What does that tell us? I guess it tells us it's working. There's an overhead in looking up in the dictionary, although I would think that the overhead shouldn't be that much compared to doing material count. Because the material count, you have to actually look at all the pieces on the board. But oh, you know what? But I think generating the fen is essentially the cost of the material count, right? Because a fen, basically counts all the, includes all the pieces on the board. So this by itself is the cost of doing material count, and then we have to do it again. So it's like doubling the cost of each of these calls for a potential savings. And the question is the savings going to be enough? We're going to depth 3. Just out of curiosity, let's see what happens at depth 2. Like, is this like instant at depth 2? I mean, it's an exponential growth, right? So as you go to bigger depths, you pay roughly 40 times more. So we should get yeah, so we're looking at, less than a second for depth 2, and depth 1 I think should just be, that's not even thinking, I mean that's just looking at material count to decide what move to make. And that's happening in, okay, 200ths of a second. So, all right, let's try depth 4 then. So this is where things get interesting. So depth 4, oops, what did I just change the 4? I thought I changed it all 3 places, but then one of them was still 3. I might have just changed something to 4 that I shouldn't have, but whatever. All right, let's just try it. So this will be slow, but I think, what did I see? Yeah, it was a few seconds. Okay, that wasn't that slow. That was 4.5. Oh, depth 3. So what did I do wrong here? I was typing. Oh, my finger was just on the 4 or the 3 button. Okay, so depth 3. What am I doing wrong? 4, 4, 4, 4. And of course, this 4 doesn't matter because it's actually not used, because the hack that I pulled in will realize that this is a false value, which doesn't make sense, and then it's going to replace it. Let's see what the output says. So look, stepping back from this, the heuristic score is helping it prune more, but comes at a cost. You have to look up in the hash table. Python dictionaries are hash tables, so you have to look up in a hash table whether you've seen that position before, and checking whether you've seen a position before is slightly expensive. Right? It's not that expensive, but we're doing it tens of thousands of times, or I guess now we're probably doing it. Yeah, so we did it 50,000 times, maybe more than that. I think this is the number of times we fully evaluated a position. I think we actually paid like 40 times this much, because we had to consider all of the next moves after this. So so there's a cost there. So if that sorting is not good enough, then it won't really provide much benefit. Okay, so what did we see? So there was a savings, right? So it went from 40 to 28, and we dropped the number of positions we fully evaluated from 57 down to 35,000. 57,000 to 35,000. Not 57 to 35,000, but both were in the thousands. And that's great, right? So we had a bunch of, we had fewer prunes because we prune the tree. So when we prune the tree, when we discover that we don't need to search anymore, and there are fewer of those, but that's because we, by realizing we don't need to search more, we don't create as big a tree, and so there's less to prune. We have a bunch of cache hits, but not as many as before. But again, there's fewer positions we're evaluating, so that's understandable. So this is promising. So now the question is, how do we get that sort heuristic to be even better? And the way that some people do this, well, the question is, how frequently are we using an actual value that we've calculated versus how frequently are we using like a bad, just the material count? And one strategy that chess computers use to handle this is they run the search at different depths. So they first run at depth 3, then they run at depth 4. And I think one way I can completely just test this out is to actually, you know what? I want to test it out, but I want to actually just play a game. So maybe we can just like call this a stopping time for my programming, and actually run some play against this bot. So it takes like a minute or 30 seconds for it to make a move, but my guess is that it's going to take less time in the future because the cache will get filled up more. So one of the things I want to do is I have to change the configuration a little bit. I think there's a way for me to So if I go to the Lichess bot script, there's a command in here that lets me view the output. So I can look at, let's see, log. How do I choose the logger? Here it is. So if I add log file, I can create a log file. Let's try that. So I'm going to just configure my run, configure the command that this program runs. This one, build deployment. No, I don't want to deploy it. There's a, how do I do this? Build tools? No. I think it's actually, maybe it's in this menu. Run. Run profile. Run custom engine. Okay, so I want to run this. Modify run configuration. Okay, so I'm running Lichess bot. I'm gonna, this is the path to it. I'm gonna give it some parameters. Great. All right, so the parameters I want to give it are -l. Let's make that. Let's be safer here. So I want log file, and then I'm just gonna call it bot log.txt, and I'll do apply, and let's run it. See if it works. All right. The question is bot log actually storing? Let's see. Do I see bot log yet? I have to refresh. Might have to get out of the IDE. Okay. How do I refresh? Reload all from disk, maybe. There we go. Okay, bot log. All right, so here we go. So let's see if I play a game how this updates. So I will just, so okay, so I'm logged in as BertBot. So should I log in as my own account? And you know what? I'll just have BertBot play against the computer. So let's try to beat Stockfish level 2, and we'll do time control unlimited. I've seen this RBot beat Stockfish level 1 very easily. Lichess lists that level 2 is approximately 1100 rated. All right, so we're running, and it's quite slow. So let's see if we're, whoops, that's not what I want to show you. Whoops, that's my terminal window, which maybe we should use, but this is not. All right, you know what? I should just open a. Oh, I know what I should do. I will close bot log here, and here in the terminal, I will have it output the bot log. Okay, so yeah, it's not printing anything. That's annoying. So that's the thing I wasn't sure about, is how do I get it to print the information I was outputting before. Because this Lichess bot app script doesn't print. It captures the output from what I was from my actual bot. So another idea I had was I could try to figure out how to use the Lichess API to actually print chat messages. Whoa, what happened? Oh. That's weird. Okay, wait, I need to. Wait, what is going on? How did, okay. So if we go back, okay, so the bot moved its knight back and forth. So it is not doing well. I thought I had changed it so it wouldn't do that kind of stuff. Is there just a complete bug now in the reasoning? Seems unlikely. But like one thing I don't know, for example, is how much how much time did it take. We can see the move times here. Oh no, you can't. It won't let me see it during the game. I think it's yeah, and this doesn't list the move times. So we can watch this, but I want to just fix this. Okay, so while it's playing, I'm gonna try to figure out how to get it to type into chat. So if I can get it to type into chat, I can just have it output that diagnostic information into the chat window, which I think we can see. Oh no, we can't see. What? Why is there no chat? Maybe this only works if I play against BertBot. Well, it's quite slow, right? So we've made 5 moves, 4 moves. We've made 4 moves. Last time we'd seen, or on offline, we saw it took like 30 seconds to compute a move, but it can take more depending on how complicated the position is. There's nothing controlling the time that it takes. Right, so one of the other things I want to do is I want to implement it to be an iterative deepening search. So it starts at depth 1, then it does depth 2, then it does depth 3. And each time it'll fill the cache up, which is good. That'll help it in the next phase, and that's a strategy a lot of chess programming, a lot of chess engines use. They sort of iteratively deepen and use the information they learned at the lower depths to figure out how to order their moves in the later depths. And so I want to do that, and then I also want to have a chess clock, right? So I want to have it know how long it's been thinking and have some strategy for how much time it should take, and then sort of, stop searching. Like once it reaches a certain time limit, it just like returns and guesses and makes the best move that it's found so far. And that would be interesting because then it could play at faster time controls and it would be weaker but faster. Like I've run this bot online a bunch of times and it just times out when people play it against, play blitz against it. It can win. It can't win. It's not good, but it can play until the end of classical time control games. But rapid and blitz, it just fails. Unless I set the depth to 3, then it just plays really fast and does terrible. So right now it's thinking really hard. I don't think it's. I mean, there's no captures, right? So the old sorting did nothing. If it's looked ahead, maybe it has some ordering of the moves, but yeah, it's hard to tell without being able to read anything. Oh, actually, wait. Were we waiting for Stockfish just then? No, now BertBot is thinking. So let's see. I want to figure out how to type into chat. I don't think we'll be able to see it in the current game we're playing because let's see, Lichess bot API. Let me show you what I'm looking at. So this is the full API. So Chess bot. So I've done all of this. Conversation. Here we go. So React. What is this? Command. Oh, okay. So I can have it create command. Wait, I can create commands. Eval. I don't tell it to my opponent. Sorry. So I guess there's some like built-in commands. I think. I wonder how much this is already working on my bot because I just set it up as like the basic bot. Like if I typed in Q, send reply. self XHR chat, self game ID, line room reply. So there might be some conversation object I might have access to. Let's see. So in here, in my custom engine, we are extending minimal engine. So if I follow back, there's also this engine wrapper, but minimal engine probably wouldn't have it. I'm guessing engine wrapper might. So engine wrapper has print stats. So there's logger.info, but our log's not showing anything, right? So this is the terminal. Yeah, our log is not showing anything. One thing I could do is I could change all the print statements into this logger call, and that might get us these outputs. That's probably the right way to do it. Let's try that. Well, let's check on the game right now. How did this even happen? Did we move our knight back and forth again? Let's see. No, we moved the rook back. We moved. Oh, I didn't notice the rook had the rook had moved for no good reason. Yeah, these are not good moves. The one question is, are these the correct moves given just trying to optimize the minimax objective to depth 4? It's possible. I mean, some weird stuff happens in the intro, not the intro, in the openings, because there's no clear advantage if you just look ahead a few moves in the opening. So it could be that's just what's happening, is that. And now, like for example, the sorting function is not going to help because it's considering captures, and both these captures are bad. So it's going to try them, and then it's going to have to then try other moves that are going to be better, and so eventually it'll find a better move than making those captures, but it'll first try the captures. But I'm going to guess BirdBot's going to slide the rook over again because it can't develop the knight, and well, I mean, did I change? The other thing I had done is I was using my heuristic that would consider space, but then I think I might have turned that off. Let's see, what does it do? Oh no, improved score. Yeah, so it should be trying to gain space. So this improved score heuristic, it counts the material and then it adds up. Wait. Yeah, it has the material count and then it adds up some estimate of how many squares we control versus how many squares the opponent controls. But oh, you know what? Another possibility is I could have broken something with the turn logic. But it was getting those checkmates correct, right? That checkmate puzzle I was showing you before, it got that correct. So I don't know. This might be correct. It's just really slow. Okay, so back to this logging. So let's see. So I had these print statements. Oh, and you know what? I didn't even think about this. These print statements aren't going to print because these are not part of the bot. They're part of the main function of this script. So in fact, I will not. Yeah, it's not surprising I don't have any output. Okay, so that's not. So the problem wasn't that I wasn't doing anything. I think we can just do print statements. I think that'll output to the console fine. Logging is the better way to do it because then we can put it in a file and we can search it and all that. So I should think about having outputs here, but there's a couple other aspects that are not good. Right? These are global variables I had set up. Right, so I have a to-do here that I'm going to refactor this to keep stats without using global variables, and right now it doesn't do that. So it's just gonna what's the word? Yeah, it's just gonna keep adding up more. There will be memes. So the question is, am I going to use reinforcement learning eventually? Yeah, I'm getting there slowly. My plan is to go through like the chess programming basics. So these are like the really older algorithms that don't even don't adapt really. They just sort of learn the rules of chess and try to look ahead as many moves as are possible. But yeah, eventually I want to do some machine learning. Much of that would take place after I do this, it would kind of stay in place, and then what would be replaced is instead of using material count or improved score, it would be a smarter score function that's learned. That's like what all these modern chess engines are using now. Even Stockfish, right, is now using a machine learning based evaluation function. Okay, so where are we now? I don't know. So it's running, it's slow. I guess maybe it won't do anything good until we do that iterative deepening stuff. So since it's so slow, I guess what I'll do is let's run it on. It is just completely stuck. Is it really even still running? My computer is, is doing a lot of stuff, but I think a lot of that is like OBS. My streaming software is taking up a lot. Python's not even on here. Is it? Did I stop it? Did I kill the job? I think I killed the engine. No, it's still running. Did it freeze? Oh, maybe PyCharm is the parent job. So my monitoring software sees it as PyCharm running. PyCharm is the development environment I'm using. Pretty slow. Are we seeing? Yeah. So there's there will be memes as referencing. There's a Transformers AI. Sorry, that's doesn't even make sense. There's an AI tool called BERT that does natural language processing, and it's a special tool called. It's a form of a transformer, and it's very popular and has caused a lot of confusion because I am a machine learning scientist who's named BERT, who has nothing to do with the BERT model. So yes, BERTbot doesn't use transformers. Although maybe I could add that in. Probably not, because I don't have the compute for that. Or I do, but I don't want to. I don't think I can use my work machines for this. Okay, so this is totally stuck. I don't understand how. Well, I think it's been like 2-3 minutes, and these things were taking. I mean, sure, there's a lot of moves available to consider, so maybe that's what's happening, but it just seems like something's stuck in a loop or something. I'm gonna cancel this, and I'll forfeit this game. Wait. Oh, you know what? I'm in the analysis board. So the game was going on. I just didn't know it. Okay, so the game was continuing. I can restart it and it'll continue from there. But this game will take forever. Let's just reduce the depth and see what happens when we continue. It'll probably lose now. I will set the depth. The way you do that is the default depth. I don't know. I'm kind of disappointed. I don't know why. Oh, this is material count. I'm not using the new heuristic. Oh, okay. So here's what I want to do. I have to set the default to somehow use the new heuristic. All right, I've been doing this. Okay, I have a few more minutes. I have time to do this. I'm gonna get this working. So right now the default is to use the material count heuristic, sort heuristic, and I don't want that. I want it to use the cached heuristic, and that should be faster. I mean, this is wasted so much time. Okay, so how do we do that? So let's set this to be. I'm gonna do none as a hack, and the hack will be that it's just so, it's so ugly. You know what? I think I'm just gonna have to. Hmm. I know what I'll do. Okay, I know what I'll do. So I set it to none, which is a hack. And inside the, I'm now going to call, I mean, one thing I could do is I could just make it hard coded to be this. That's what I'll do. I'm gonna hard code it to always use this. So instead of this nice thing that I did, I'm just gonna set it to always use the cached. Oh shoot, I can't because it doesn't have known positions. Oh, I know. No. This is so ugly. All right, let's just leave it this way. So I'm gonna do sort heuristic, and I'm gonna make that something that you have to pass in. So sort heuristic, and by default it will be material count. Oh man, okay. It's complaining about this because what? Nope, there's nothing wrong with it. All right, and just quickly to patch this in, I will. Oh, I have to change it every single time I call minimax score. So this is where I was talking about that repeat code. Sort heuristic is at the end, so we're just going to say sort heuristic, copy, paste. So that's some bad coding where I just copied something twice, and we need to be more modular, more organized. And then when I call it here, I need to give it a score function. I do not like what I'm doing, but it's eventually I will always use a sort heuristic, so it's all right. So this is not good. I actually want this to be. What am I doing? This is all right. Why is that red? Why is this red? Oh, I think it's because I have to say sort heuristic equals. Yeah. Okay. So I've done this, and now I will just. I think this will work, and then I'll just let it run. Now I don't want that log. Let's change the run configuration. Edit configurations. Let's turn off these log options. I just print it to the console. Okay, so we're connected to Leech Chess, and this game will resume. But it won't output anything. That's fine. We don't want it to output anything. So now now it should be using the sort heuristic. Now while it's running, I can just read the code and make sure I did it correctly. So we're sorting by the sort heuristic, whatever it is, and that's material count by default. But if we passed in something, we would use something else. Anytime we call minimax score, we also give it the sort heuristic again, so it's going to reuse the same heuristic throughout every child call. Known positions. So we have this cache score. The search function then uses the cache score as the heuristic no matter what, so it doesn't even consider the configuration anymore. So now, okay, so now I'll just leave a note for myself because I will won't have time today to fix this, but configuration currently does not, here, let me put this as a to-do so that the IDE flags it. Configuration currently does not consider the sort heuristic. It's hard-coded to use cached score. So I have to remember that because this main function here is set to compare the sort heuristics, and right now it will always use the cached score. So let's see, are we making moves? No, it doesn't look like we're making moves. Let's end this game. I'm gonna log in with my account and play against BurtBot. All right. So let's challenge BurtBot to, let's do an unlimited game. Not rated, I don't want to do rated. Okay. Let's see how long it takes for it to make a move. So there's a chat window here. I do want to at some point figure out how to make chat, or make the bot chat stuff. Because I was thinking you could, one thing that would be interesting is to have a chat, like its current estimate of, how it's doing. So we can sort of see whether it thinks it's winning. Again, that's a really bad move. I don't know why. I don't know. I worry that it's not. I don't know why I would think that's a good move. I mean, does that get more space than developing the knight toward the center? I don't think so. I think that the space would be better if it developed the knight toward the center. So that seems like a bug. Seems like a mistake. Oh, you know what I should have done? I should have done a time game so I have an estimate of the time. Well, I can't play. I probably can't finish this game at this rate. Okay, yeah, that's a terrible move. Something must be wrong. Let's try depth 3 just as a, well, I don't have to forfeit. I can actually continue. So I'll just set the depth to 3 and reboot the bot. So I do that here. Set it to depth 3, so it should be pretty fast. And just kill the job and restart it. I think this should work if I just I'll do something. I'll move my knight back and forth to give it a chance. Okay. Something doesn't look right. All right, let's just get the game further in and see if it does anything reasonable. I think I might have, maybe I put the moves out of order somehow. Yeah, that doesn't make any sense. I'll just get more space. I remember an earlier version of this bot seemed like it was acting like this, where it just was playing really terrible moves, and then all of a sudden it started calculating way better than I could. Probably because, again, some of that is just like the weird stuff about the opening. So in the opening, like I said, there's not much material advantage no matter what move you make. So it's hard to figure out what to do in those situations. So as the game gets more tactical, the Minimax algorithm really starts to shine. So if things are working correctly, yeah, that is, it's not working correctly. There's no way that was a good move. Looking ahead 3 moves, I mean, that was so what was my bug? It could be the turn thing. Maybe I did something wrong with the turn, so it doesn't know whose turn it is. Yeah. Well, looks like next session will be debugging. Too bad. Yeah, that's annoying. Uh, it's slow and wrong. So when this session began, it was slow and correct. And now it's still slow and wrong. Let's just take a pawn. I don't know. Is it even fun for me to beat this bot that's playing random moves? It's not even random moves. It's like worse than random moves. If it was random moves, it would do something other than move this rook back and forth, which it's absolutely going to move that rook. Like I'm sure it will just. Okay, that is worse than moving the rook. Whoa, that is hardcore spam. And let me look. Okay, well, thanks for letting me practice blocking people. Um, I don't know if people see the chat. Someone's trying to sell me followers. So let us block this person. I mean, unless you're like into chess and programming and into selling followers, if you want to do that, then that's cool, I guess. But I'll probably block you anyway. So how do I do that? It's the first time I've ever done that. Ban. Cool. Okay. All right. Well, I'm gonna call. Okay. Yeah. Nice job, BirdBot. Move that king. Yeah. Start attacking with that king. I'm gonna end this. So the conclusion today is that maybe I improved the pruning algorithm, but unlikely because now it's making really bad moves. So more likely I just introduced some bugs that are that'll take some time to track down. So all right, thanks for watching. I'll probably try to do this more. I did this yesterday. I did it today. I guess I do it more the more I have to procrastinate. So maybe I'll do some more tomorrow, but I probably shouldn't. I need to actually get a lot of my own real work done. So anyway, stay tuned. I'll stream soon.